All right, so our goal for today is to identify parts of a circle, and we'll find measures of arcs today too, so we'll do both objectives. We'll spend a little bit more on Monday. So the vocabulary words are all going to go in that first box. So the first one is just the definition of a circle. A circle is the set of all points in a plane that are the same distance from a point called the center. And we know how many degrees are in a full circle? 360. And anytime you name a circle, like you'll see it in the directions, they'll put a circle with like the center, and then they'll put the letter next to where the center is if they're naming it. All right, the next two kind of go with this picture. We have a segment who has one endpoint on the center and the other is an endpoint, so that would be our radius. Which again, we should know all these, most of the terms. The major arcs you probably won't know, but a lot of this is a review. A segment that contains the center and has both endpoints on the circle, so it goes through the center and it has endpoints on the circle, is your diameter. What is the relationship between the radius and the diameter? Huh?
The radius is half.
Good. The radius is equal to 1/2 the diameter. And what's the relationship between the diameter and the radius? So the diameter would be equal to what? 2 times r. Very good. So if they give you one, you can find the other. Next vocabulary word, we have 2 circles that have congruent radii. So when we did like a trapezoid, there were lots of measurements. There's base 1, base 2, and height and the sides. In a circle, there's actually only one measurement that makes a circle, and that's the radius. So if they have the same radius, then they are called congruent circles. When we did triangles, we had to prove like SAS, ASA, all that stuff. In circles, you just have to look at the radii to see if they're congruent. Radii is plural for radius, so that you're not saying radiuses. In case you've never heard that before. All right, the next one, an angle whose sides are radii, and the vertex is at the center of the circle. Those are called central angles, because they touch the center. The vertex is the center of the circle. Do you remember how to name angles using 3 letters? What would I call this angle? 2 possible names. AOC or COA. Technically, you could call it angle O because it's the only angle in the picture, but usually there's going to be more than one. Just reviewing that. We will learn that the central angle is going to be equal to the measurement of the arc, but maybe we'll do that down here. Maybe. So if it's a central angle, the measurement of the arc will be the same because there's 360 degrees in a whole circle. So if this is 45, AC would be 45 degrees. All right, the next one is an arc that is half the circumference of the circle. So again, if you have a highlighter, you might want to go ahead and highlight that part. What do you think that would be called? It's half of a circle. Semicircle? Have we heard that before? Half of a circle? Semicircle? How many degrees would be in a semicircle? 180, half of 360. My unit circle people know this. Wow, right? The endpoints will always form a what if we connect them? A what? A segment, but more specifically, a diameter. Because it'll go through the center and it'll be a segment. All right, the bottom parts are our arcs. The first one is just a definition of an arc. An arc is a portion of a circle that lies between 2 points. So for example, AB would be an arc. So would BC and so would CA, but I'll just mark one of them. Now there's 2 ways that you can classify arcs. So these are like underarching ways you can classify them. As a minor arc or as a major arc. And that's all depending on how many degrees it is. So a minor arc is an arc that is less than half the circumference. So it's also less than 180 degrees. You name these only using 2 points. And there's an arc notation that you'll put on the top. So an example of a minor arc would be AB. Now the reason that you'll specify with only 2 letters, technically, if you think about it, AB could be this whole thing, right, too? Because if you go counterclockwise, that's going to be called a major arc because it's over half of the circumference, over 180 degrees. So those are called major arcs, and we're going to name those using 3 letters so that you can differentiate between the 2. Hi there. In honors geometry, you can't answer right now. So a major arc is one that is more than half the circumference, meaning that it is greater than 180 degrees. And you're going to name this using 3 points. And let's also add another point on here. Put like I don't know, X there. So an example of a major arc would be, and there's more than one, but I'm just drawing one of them, would be this one. It is only named with 3 points. Even if there were 17 points that like went around, you would not list all of them. So you will use the first one and the last one, and you can use either of the 2 that are in the middle. It doesn't matter which one. So you could call this arc A, B, C, or you could call this arc A, X, C. Technically, you could call it CXA, but usually we go clockwise, just because it makes it easier if we all go clockwise. But the reason that you need the 3rd letter is so that you do know which direction to go. So it kind of like guides you. Go ahead and put down that you would never call this A, B, X, C. Okay, do not use 4 letters or 5 letters. You only use 3. The 2 endpoints and then one of the in-between points. All right, so on the back, what we're going to do is identify these things in some complex pictures. We got lots of stuff going on. So this first example goes with the first picture. Oops. Who can identify the center? Marquise? Yes, we'll actually say point O, since it is a point, just like we used to do like segment and ring and all that stuff. A little point there. How about radii? There are more than one. Who can give me a radius? Maddie? Close? Segment. Segments, yeah. Or segment OC, doesn't matter. CO touches the outside of the circle and the inside. Again, the order does not matter. You don't have to list both of those, only list one of them. Now who can tell me a different radius? That's the picture. Helen? Segment BO. Are there any more radii that touch the center and touch the outside part? No. I wish I would teach you all the parts of the circle right now. So we're going to learn what the chord secant and tangent are, but for some reason this are saved to chapter 12. All right, diameter.
There's none.
Huh?
There's none.
None. Very smart. There is not a point, segment that goes through the center that touches both sides. All right, now minor arcs. There are lots of them. So there are many. Let's just list a few. So just put many possible. I'll give you one to start out. Remember, minor arcs are smaller than half the circle. So CB would be a minor arc. Would CA be a minor arc?
Yes.
Yes. Why wouldn't I call it CBA?
That would be major.
That would be a major arc. Okay? So even though this passes over another point, you only would name it by the two endpoints because it's a minor arc. So this would be arc CA. Because it's still less than 180 degrees. We only use two letters. Who could give me another one? There's lots of them in this picture you could come up with. Marquise?
GB.
Arc GB. Yep. Who could give me another one? Maddie? Arc what? AB. AD. AD, yes. AB would also be one, if you wanted to. Anyone give me another one? Come up with a million of them. FG, GC, FC would be one. Let's put that one down. Because it skips over one of those points. Now the reason you would know that arc FC was not this one is that that's a major arc because it's bigger. So that's how you know which direction to go. All right, let's switch to major arcs. And then let's go to central angles. Who could give me a major arc? There are many of them as well. Brett?
Would FAG be a major arc? Because it's really big.
Yes, what's another way we could name that? Marquise?
FG.
No. If you call it FG, you'd be talking about this one. Are we really that immature?
Yeah.
I didn't point at anyone.
GAL.
You could call it FBG, which might be a little bit more politically correct here. Or you could call it FCG. Brett, I'm about to revoke your homework extension for that. All right, who can give me another one? Matt? Maddie? We only use 3 letters though. We need another letter. Keep going. No, that one. BDG. You also could have done BGC to add, like, you can go all the way, just as long as you don't go to one complete circle. Marquise?
Arc CAF.
Arc CA. Yes, if you were to connect these, you would realize it's not a diameter, it's definitely bigger. All right, that's enough. Matrix. Who can identify a central angle? Noah? Good. That's the only one. You could also call it VOC, but that's the only central angle. We'll learn later that these angles are called inscribed angles. They're not central. All right, see if you can identify all of the minor arcs, semicircles, and major arcs that contain point A. I want you to try and get all of them. There are 4 of each. if you come up, make a note that semicircles are named using 3 letters. So this would be like X, W, Z. Semicircles use 3 letters. Just to tell you which semicircle. If you said X, Z, you could be talking about this one or this one. So that's fine. Last part, we have an arc addition postulate. Remember the segment addition postulate where we added 2 segments? Same thing. In order to use it, though, you have to have what are called adjacent arcs, meaning that they are next to one another. Formal definition is that they have exactly 1 point in common. So they're not overlapping, but an example would be arc AB and arc BC. Those would be adjacent arcs. They don't overlap, they just share that 1 common point. And so you can add the measures of the arcs just like you would add adjacent angles or segments. So the measure of arc ABC would be equal to the measure of arc AB plus the measure of arc BC. Okay, so just showing that you can add these together to figure out the total arc. So down here we have some measurements given to us. Before you start finding, and these are supposed to be arc symbols, they're like kind of look like they're V's, but they're supposed to be arc symbols. First thing you might want to do is just go to the picture and find all the angles and the arcs using addition and subtraction. So notice how this is a semicircle. A semicircle has 180 degrees in it. So what would this angle have to be? Angle BOA. Marquise?
148.
148. On the other side,
Please excuse this interruption.
if this is 58,
District Medlin, please report to the guidance office.
that's 58. Central
District
angles
Medlin,
and central
please
arcs are
report
the
to the
same.
guidance office. Thank you.
So what would the measure of angle DOA have to be? What would the measure of angle DOA have to be? Marquise?
122.
122. So all we're doing is just some simple subtraction. Sometimes they'll be harder than that. And then you do want to notice that any of the central angles will have the same measurement as the arc. So I would just always go to the picture and find all the missing angles and arcs, and then you can go to the problem and add some of them together and find your measurement. So arc BC, we already see it's 32. Measure of arc BD. How big would BD be? Luke? It would be 90. 32 plus 58. All right, now the next one has 3 letters, so it's going to be a major arc. So arc A, B, C is how many degrees? 180. It's a semicircle. And the next one says measure of arc AB, which we see here is 148. See if you can complete the 4 closure questions, which are dealing with this.